In this class, we'll be solving another problem on concrete mix proportioning as per IS 10262 2019. So this problem also has some uniqueness compared to the other three problems that we have solved. Only one or two places you can find some difference, or else all the methods what we have done in the other three problems, it is almost same. So I'll directly go on to the problem. So design a concrete mix as per IS code procedure for the following data. So these are the data for mix proportioning. Characteristic strength at 20 days 30 Newton per mm square, that is FCK. Type of cement, so it is PPC, that is Portland Pozzolana cement. So till now we have done with OPC 43 and 53 we have been using. Then in this problem, a small change that I have made is that we have used PPC cement in place of OPC. So PPC conforming to IS 1489 part 1. So this is IS standard for IS code for PPC. Maximum nominal size 20 mm, because for almost all our RCC works we are using maximum size of 20 mm. So that's why you can see in all the problems the maximum size is 20 mm. Then degree of workability is zero point 0.9 compaction factor. So this is one change in the problem, because till now all the problems we have given with the slump value in mm. So in this problem they have given the compaction factor. So how we can able to find the water content by using this compaction factor, that you have to that we'll be learning in the coming slides. So exposure condition severe, degree of supervision good, then type of aggregate crushed angular aggregates, then minimum cement content and maximum water cement ratio is based on the exposure condition. I'm keep on repeating every time. So if exposure condition is given, then they may not give minimum cement content and maximum allowable water cement ratio also. If the exposure condition is given, then you have to refer IS 456 codebook to get minimum cement content and maximum water cement ratio. If the IS 456 is not given in the exam, then it's better you remember the values for all the exposure conditions. Okay, so 90% or 95% I can assure you that these values will be given in the problem, but remaining 5% I can't assure you. So if the exposure condition is given, it's your job to know what is the minimum cement content and maximum water cement ratio by referring the code book, that is IS 456. It is not available in IS 10262 2019. It is there in IS 456, but in your exam IS 456 may not be given. Okay, so in that case you cannot ask the faculty who is invigilating, or you can't say that the question is wrong, they have not given the data. So it's your job to remember the minimum cement content and maximum water cement ratio based on the exposure condition. Okay, so that's why remember the value by referring IS 456 codebook. If the value is given, then no problem, then you don't have any difficulty at all, you can easily solve, or else remember the value. Next, chemical admixture nil. So till now they have been given chemical admixture as superplasticizing. In this problem we are not using any chemical admixture, and we are not using any mineral admixture also. So test data for materials: cement specific gravity 3.15 standard, specific gravity of coarse aggregate and fine aggregate 2.72 and 2.64 respectively. And here also, sometimes in some question paper, if you refer, which I have shared in Google Classroom, so sometimes they have given assume test data suitably. Okay, so then you have to assume the values. Okay, so then you should know what is the specific gravity of cement, what is the specific gravity of fine and coarse aggregate. At least you should know the range. Okay, sometimes they will give it as assume all the test data suitably, then you have all the provisions to select your own values. But while selecting, make sure that the value that you are writing as a specific gravity is within the range. Okay, so for specific gravity of fine and coarse, it should be around 2.6 to 2.8. So if you write below 2.6 and if you write below above 2.8, then it might be wrong. Okay, so based on the range you select the data if they have given as assume, or else whatever they given the data you can take that as for the calculation. Next, water absorption coarse and fine aggregate 0.5 and 1% respectively. Then moisture content, coarse aggregate 1% and fine aggregate 3%. So here they have not given free surface moisture. So instead of free surface moisture, they have given us moisture content. So both are same. Don't get confused. Okay. So free surface moisture or moisture content is one and the same. So 1 and 3% respectively for coarse and fine aggregates. Then sieve analysis, as most of the time coarse aggregate will be conformed to table 7 of IS 383 codebook, and fine aggregate it will be conformed to the zones as per IS 1 IS 383 2016. So as already told, it will be either zone 1, zone 2 or zone 3. Zone 4 is not used for RCC works because it is finer sand. So either you will be getting zone 1, zone 2 or zone 3. So in this case it is zone 1. So directly we'll jump on to the first step, target mix proportioning. We are doing all this from previous three problem. So f dash ck is equal to fck 30. They have given characteristic strength at 20 days is 30 Newton per mm square. So 30 plus 1.65 into standard deviation. So assume standard deviation for M30 is 5. So 5, which is equal to, if you calculate, you will get 38.25. Similarly, f dash ck is equal to fck plus x is the constant for the grade of concrete. So 30 plus grade, the x value for M30 grade is 6.5. So 30 plus 6.5 will get 36.5. Higher of these two values should be adopted for the further calculation. So target strength is equal to 38.25 Newton per mm square because it is higher than 36.5. So when you cast the mix proportion, I am repeating this also for every problem so that you should not forget. So when you cast the concrete based on the mix proportion that will be obtained at the last, then this when you calculate the strength after kept for curing for 28 days, then the strength should be obtained in the range of 30 to 38.25. Okay, so 95% of the strength should be more than 32, like 302 38.25, and only 5% of the test results can be less than 30 Newton per mm square. Remaining 95% it should be in the range of 30 to 38.25. Okay, then only we say that it is M30 grade concrete. Next, appropriate air content. So in the previous problem they have given the air content, so we assume whatever the data was given in the previous problem. So in this case they have not given any data regarding the air content. So based on the maximum size of the aggregate, 20 the volume of air content percentage is 1. So volume of air content is equal to 1%, that is 0.001 m cube. Next, selection of water cement ratio. So the target strength that is obtained is 38.25. Okay, so here you have to be careful. As I already told, the type of cement, till now in the previous three problems we have given OPC 43 or 53. So it was easy for you because curve 1 says for OPC 33. I have given the screenshot at the bottom. So curve 1 is for OPC 33, curve 2 is for OPC 43, and curve 3 is for OPC 53. None of the curve gives for Portland Barcelona cement or Portland slag cement. But in the note, they have said that in the second point, if you read, you will get to know. If you are using Portland Barcelona cement or Portland slag cement instead of ordinary Portland cement, then curve 2 can be utilized to find the water content. Okay, so in the second point, they have clearly given. So in this case, we are using PPC. So we have to use curve 2 because it is given in the code book. If you use curve 3 or curve 1, it will be wrong for a PPC or PSC. So you have to use curve 2 only to find the water cement ratio. So 38.25 was the target strength that is obtained from the first step. So from the y-axis 38.25, draw a line horizontally so that it touches the curve 2, and then drop a line vertically so that it touches the x-axis, that is the water cement ratio. So we have been doing in the previous three problems in this way. You can see in the red line which I have drawn. So based on 38.25 target strength and based for the curve 2, and as per curve 2 the water cement ratio, that is 0.43. So approximately it is 0.43. So from the grade curve the water cement ratio is 0.43. But what the based on the durability aspects, what is the maximum water cement ratio? So for the severe exposure condition, the maximum water cement ratio is 0.45. Okay, so that is given as per table 5 of IS 456. So whatever the value that we get, it should be uh, less than the water cement ratio given in the code book as per the durability exposure condition. So lesser of the two values have to be adopted in in between 0.43 and 0.45. The lesser is 0.43, which is obtained from the grade curve. So 0.43 is adopted for the further calculations. So you know that lesser the water cement ratio, higher will be the strength. So that's why always whichever the value which is lesser, you have to consider that for the calculation. I hope you understood this part, especially for PPC. So next, very important, this we have not done in the previous three problems, because in the previous three problems they are directly given the slump value. Based on the slump value, we used to calculate the water content. But here in this case, they have given compaction factor. Okay, so this table is taken from SP 23 codebook, that is a handbook for concrete mixes. So you can see they have given a uh, ranges based on the different test workability tests. Okay, so just I will read out. Say for medium, so for placing condition, that is for lightly reinforced section without vibration, or heavily reinforced section with vibration. So if you are doing a concreting for this type of construction, then the degree of workability should be medium. So medium means that when you are doing a test, this should be the ranges. Okay, so when you do the VB consistency test, then the workability should be within 5 to 2 seconds, 32 to 5 seconds, because VB is expressed in seconds. Similarly, compaction factor, it should be in the range of 0.85 to 0.92. Similarly, for the slump, it should be in the range of 25 to 75 mm. So if the compaction factor is given in the problem, if they have not given the slump, so then you will have the range. Say if the compaction factor is in between 0.85 to 0.92, then the slump you should take is in between 25 to 75 mm. Okay, similarly, if the compaction factor is given as a 0.83, okay, sorry, for low there is no slump value. Say if the compaction factor is given as 0.92, okay, or more than 0.92, say 0.94 is given as compaction factor, then then you should know what should be the slump value for the compaction factor of 0.94. So the slump ranges from 75 to 125 mm. This you should remember. Okay, so this is as per SP23 handbook for concrete mixes. So this you may find it little difficulty. So I have a similar table in the next. Okay, so I think this you can remember. So definitely this you can remember. Say if the compaction factor is given as 0.86, so it is in the range of medium 0.85 to 0.92, then you can have to select the slump value of 50 to 75 mm. Similarly, if the compaction factor is given as 0.84, then it is in between 0.80 to 0.85, then you have to select based on that. The slump ranges from 25 to 50 mm. So if the slump is directly given, then there is no problem at all. You can directly do with the steps whatever we did in the previous three problems. But only when if the compaction factor is given, then you should know based on the ranges of the compaction factor what is the slump value, because code book says only for the slump, not for the compaction factor. If you refer IS 10262, so for 50 mm slump they have given a table, not for compaction factor value. So but in the data, if they give compaction factor, then you should convert that into corresponding slump value. How to convert? That means you have to remember this values. Okay, so for our problem, just I'll go back. So our problem, they say that the compaction factor is zero point 0.9. So degree of workability, that is zero point 0.9 compaction factor. So for zero point 0.9 compaction factor, it falls in the range between 0.85 to 0.92, right? So since it is falling in the range between 0.85 to 0.92, so the corresponding slump is 50 to 75 mm. Okay, so this is how you have to take the slump value based on the compaction factor value. Okay, So this table you need to remember, you have to by heart. So there is no other option for you, because if the compaction factor is given, they will not give the slump value. Okay, so based on the compaction factor range, you have to take the slump value. So that's why this you have to by heart. Instead of by hearting this table which is given in SP23, so you may find it little difficulty. So that's why this is one of the uh, values which I have done. This is the table that I have taken from the gate book which I am having. So from the gate book I have taken this value. Okay, so you can remember this. Now I'll move on to the fourth step. For the workability zero point 0.9 compaction factor, I know that it falls in the range of 50 to 75 mm. So I have taken for 75 mm slump. Okay, it should be 50, it can be 50 mm slump also, or it can be 75 mm slump also. So I have taken the higher value. Okay, so table 4, 20 for maximum size 20 mm, the water content is 186. So this is for 50 mm slump. So we want for 75 mm slump. So for every 25 mm increase in slump, we have to increase the water content by 3%. So it is, I have highlighted in the code book also, it is given, just I have highlighted it. For 25 mm increase in slump, you have to increase the water content by 3%. So 186 for 50 mm plus remaining for 25 mm. So I have increased the water content by 3%, that is 3 by 100 of 186. If you calculate, you will get 191.58. So I have rounded off to 192 kg per liter. So since here not given any chemical admixture, no need to assume. Okay, I am clearly telling you, if they have if they tell you to use chemical admixture, that is super plasticizer, only then you can uh, use that you can use that data to reduce the water content, or else no need to assumes there is that we are using admixture and to reduce the water content, since they have not given any data regarding super plasticizer. So no need to uh, take the percentage to reduce the water content. Okay, directly you can keep it as 192 kg per liter only. Is anyone having a doubt? Okay, because someone has unmute their audio, so that's why I asked. So 186 plus 3% of 186, you will get 192 kg per liter. Since we are not using any admixture, you can keep it as it is, 192 kg per liter only. Next, calculation of cement content. Water cement ratio from the grade curve that we have used is 0.43. Then cement content is equal to water content divided by water cement ratio. So water content is 192 in the previous step we have found out, divided by 0.43 is the adopted water cement ratio from the grade curve. So you will get 446.51 approximated to 447. So this 447 you have to check with the durability aspects also. For very severe condition, the minimum cement content is 320. So whatever we got the value of 447, it is more than 320, so not a problem. But the maximum cement content also we have to check. So maximum cement content is 450. So whatever the value we got, it is in between 450 to 3 it is in between 450 kg per m cube and 320 kg per m cube. So our value is within that range, so not a problem, we can adopt the same water same cement content. So only when, if the cement content is more than 450, if you get the value of more than 450, then you have to take the maximum 450 only, whatever may be the value. Even if you get 470, 480 and all, so the maximum you can take from the code book is 450 only. Okay, so our value ranges between those two value of maximum cement content and minimum cement content. Hence, okay, 447 we can use it as the cement content. Next, proportion of volume of coarse aggregate and fine aggregate content. So as you all know, in the data they have given for zone 1, so this table is prepared for the water cement ratio of zero point 0.5. So for the water cement ratio of zero point 0.5 and for maximum size of aggregate 20 mm, and for the zone 1 fine aggregate, the volume of coarse aggregate is 0.60 for 20 mm maximum size. For the zone 1 of fine aggregate, the volume of coarse aggregate is 0.60. Okay, so for zero point 0.5 water cement ratio, the value is 0.60 as per the zone 1. But now whatever the water cement ratio that we have adopted is 0.43. So it is less by 0.07. So compared to the benchmark data of 0.5, our water cement ratio 0.43 is reduced by 0.07. So in the what the code says, for every decrease in 0.05 water cement ratio, you have to increase the volume of coarse aggregate by 0.01. So I have split it up. So our water cement ratio is lower by 0.07. So for 0.07, I have split it as 0.05 plus 0.02. So for every decrease in 0.05, uh, you have to increase the volume of coarse aggregate by 0.01. So next remaining is 0.02. So I have given a small calculation at the bottom. For 0.05, you have to increase the water content by, so you have to increase the volume of coarse aggregate by 0.01. So for 0.02, if you calculate 0.02 into 0.01 divided by 0.05, you will get 0.004. So for um, decrease in the water cement ratio of 0.07, you have to increase the volume of coarse aggregate by 0.01 plus 0.004, you will get 0.014. Now what is the corrected volume of proportion of coarse aggregate? uh, Volume of the water cement ratio that we adopted is 0.43. So on the right hand side, after increasing it by the codal provision, so you will get 0.614, that is 0.60 is for water cement ratio of 0.5, and remaining 0.014 is the corrected proportion for our water cement ratio of 0.43. So totally we will get, for 0.43 you will get 0.614 cubic meter. Okay, I hope this part you understood, because we have done in the previous three problem also. Next, here they have not given the method of placing. They have not given anything regarding the method of placing. So only if they give method of placing as pumping, then you have to reduce the volume of coarse aggregate by 10%. Okay, that means the volume of coarse aggregate you have to multiply by 0.9. But here in the data they have not given anything regarding the method of placing, so no need to assume it as pumping. Only if the data is given as method of placing as pumping, then you have to multiply by zero point 0.9, or else no need to do that step. Okay, so volume of coarse aggregate obtained is 0.614, and volume of fine aggregate is 1 minus of 0.614, you will get 0.386 cubic meter. Okay, so next is mix calculation. So total volume is 1 cubic meter. So I am keep on telling this, whatever we do the mix design, it is for 1 cubic meter of concrete. So total volume of concrete is 1 cubic meter, and the volume of entrapped air, in the second step we have found out it is 1%. So 1 by 100 you will get 0.01 cubic meter. Then volume of cement, you know the formula, mass of cement divided by specific gravity of cement into 1 by 1000. So mass of cement is 447 divided by specific gravity 3.15 into 1 by 1000, you will get 0.141 cubic meter. Then volume of water, we have found out it is 192 in the uh, third step, sorry, in the fourth step we have found out that is the mass of water is 192. So 192 divided by specific gravity of water is 1, so we will get 0.192 cubic meter. Then since we are not using any chemical admixture, or we are not using any mineral admixture, directly you can go for volume of all the aggregates. So volume of all the aggregates is equal to A minus B minus C minus D. If you remove the bracket, you will get A minus B minus C minus D. So which is equal to 1 minus of 0.01 minus 0.141 minus 0.192. So if you do that, you will get 0.657 cubic meter. That is volume of all the aggregates. It is 0.657 cubic meter, including coarse and fine. Now we know the mass of cement, we know the mass of water. The another two masses which is left is mass of coarse aggregate and fine aggregate. So mass of coarse aggregate is equal to E into, E is the notation, so E into volume of coarse aggregate into specific gravity of coarse aggregate into 1000. So E, just you substitute 0.657 that we have calculated volume of all the aggregate into volume of coarse aggregate we have found out in the previous step as 0.614 cubic meter. So multiply that 0.614 into 2.72 is the specific gravity of coarse aggregate which is given in the data, you can refer that, into 1000 is equal to 1097.24 kg, have approximated to 1098 kg. Similarly, mass of fine aggregate is equal to E into volume of fine aggregate into specific gravity of fine aggregate into 1000. E is 0.657, we have calculated in the volume of all the aggregates 0.657, and volume of fine aggregate we have calculated 1 minus 0.614, you will get 0.386. into 2.64 is the specific gravity of fine aggregate. It is given in the data. Into 1000 you will get 669.50 kg. Have round it off to 670 kg. So these are the mixed proportions for the trial number 1. So cement is 447 kg per cubic meter, water is 192 kg per cubic meter, fine aggregate 670 kg per cubic meter, and coarse aggregate 1098 kg per cubic meter, and fine aggregate 0.43 cubic, sorry, 0.43. So fine aggregate and coarse aggregate, as you all know, it is the code book says it is calculated for SSD condition, but in the data it is given that there is a free surface moisture present. Okay, so if the free surface moisture present, then it indicates that both fine and coarse aggregate it is in the wet condition. Okay, so we have to do the adjustment on water, fine and coarse aggregates, because both the coarse and fine aggregate it is in wet condition. You can see at the bottom, they have taken a screenshot from the data. They have given that water moisture content, that is free surface moisture, for coarse aggregate it is 1 and fine aggregate it is 3. In the previous problem, if you remember, coarse aggregate was given as nil and fine aggregate was given as 2%. Okay, some 2 or 3% it was given in the previous problem. That indicates that coarse aggregate is in dry condition, fine aggregate is in wet condition. That is for the previous problem. Based on that we have uh, adjusted the water content, but here both fine and coarse aggregate are in the wet condition. So fine aggregate in wet condition is equal to mass of fine aggregate in SST condition into 1 plus of free surface moisture divided by 100. Okay, so this is the formula for the wet condition. Okay, if you take formula for dry condition, then mass of fine aggregate in SST condition divided by 1 plus of water absorption by 100. That is a formula for the dry condition, but here we are using for the wet condition, so that's why it is into 1 plus of free surface moisture by 100. So mass of fine aggregate in SST condition we have found out in the previous slide, that is 670 kg per cubic meter. So 670 into 1 plus of free surface moisture given as 3% for fine aggregate, so it is 3 by 100. If you calculate you will get 690.1. I have approximated to 691 kg. And coarse aggregate also it is in the wet condition. So mass of coarse aggregate in SSD condition we have calculated, that is 1098 into 1 plus of 1 by 100. So 1 is the free surface moisture for the coarse aggregate. So into 1 plus of 1 by 100, if you calculate you will get 1108.98 kg. So I have approximated to 1109 kg. Okay. Now if you see the values between SSD condition and the wet condition, so in SSD condition it was 670, now in the wet condition it is 691, and for coarse aggregate in SSD it is 1098, but in the wet condition it is 1109 kg. Based on the free surface moisture, this is what the fine aggregate value has been changed from SSD to uh, wet content. Okay, you can see how the numbers have been increased. So this much amount of water is present in the uh, fine aggregate for 1 cubic meter of concrete. Now what is the water content contributed by both coarse and fine aggregate? So here water content contributed by fine aggregate is equal to mass of wet fine aggregate minus mass of fine aggregate in SSD condition. So mass of wet fine aggregate is 691. We have calculated in the previous step, 691, minus of mass of SSD in fine aggregate, it is 670. So the difference between those two is 21 kg. So based on the free surface moisture present, the water content has been exceeded by 21 kg for 1 cubic meter. Okay, so you can see how much the extra water is present in the uh, fine aggregate. Similarly, water content contributed by wet coarse aggregate, same formula. So I have forgot to change this mass of wet coarse aggregate minus mass of SSD condition coarse aggregate. It is not fine aggregate. Uh, Please excuse for that. So mass of wet coarse aggregate is 1109 kg, and minus of mass of coarse aggregate in SSD condition it is 1098 kg. If you take a difference between those two, so you will get 11 kg. So based on the free surface moisture present, so there is a extra water present in the coarse aggregate for 1 cubic meter of concrete. So if you keep this in the wet condition and if you add the same amount of water what we have calculated as 192, then it will be a lot of water that will be present in the concrete, that leads to a lot of undesirable properties in the strength as well as in the durability. So that's why we have to reduce it, the water content whatever we obtained extra by the whatever the water content that we have found out. So the requirement for water to be added is equal to 192 was the water content that we have found out, minus of 21 kg that is obtained from fine aggregate, and minus of 11 kg it is obtained from the coarse aggregate. So whatever the extra water that we have obtained, so that water has to be deducted from the total water content that we have calculated. So 192 minus 21 minus 11 gives 160 kg per cubic meter. So now this will be balanced because already fine and coarse aggregate it is in the wet condition. So we have deducted based on the percentage of free moisture, we have deducted that from the total water content. Now total water content was 192. Now we have to add 160 kg per cubic meter because of the wet and because of the wetness present in the fine and coarse aggregate. After doing this adjustment, so this is what the mixed proportion adjustment for the wet aggregates. Cement remains the same, 447 kg per cubic meter. Water earlier it was 192 before adjustment, now it has become 160. And fine aggregate earlier it was 670, now it has become 691. And coarse aggregate earlier it was 1098, that is in SSD condition, now it is 1109. And the water cement ratio remains the same, 0.43. So if you take the final mix proportion, 447 is one proportion of cement. So for fine aggregate 691 divided by 447 you will get 1.54. Similarly for coarse aggregate 1109 divided by 447 you will get 2.48. But if you remember the previous problem value, okay, for M45 grade concrete we did the previous mixed design problem. So if you remember the value, it is more or less same. So there also it was 1.1 is to 1.54 is to 2.48. But what is the difference between previous problem and this problem? So previous problem, if you remember, for the same mix proportion, the workability was 1 for 125 mm. Okay, so here what is the workability? It is for 75 mm. Okay, but in the previous problem we have used the chemical admixture, but in this problem we have not used the chemical admixture. So by using chemical admixture what will happen? For the same mix proportion, okay, if we use the chemical admixture, then the slump value, the workability aspects will be improved by adding chemical admixture. So that's why in the previous problem for the same mix proportion the slump was 125 mm because there we have used the chemical admixture. Okay, and also there we have used the fly ash also, and there we use the method of placing as pumping also. But here those things are all not there, so that's why even for the same mix proportion, since we are not using chemical admixture, the workability range is less, so it is between 50 to 75 mm. And also with the previous problem the water cement ratio, if you remember, it was around 0.34, but here the water cement ratio is 0.43. Why? Because there it is for M45 grade, so if you go on increasing the strength, so you will be decreasing the water cement ratio. But here the strength is M30, so 0.43 is more than enough to get to achieve the strength. So this is what the final mix proportion for this mix design, that is 1 is to 1.54 is to 2.48. So that ends the problem.